Hey, let's go. We are starting our workshop. I would say this is more of a webinar style workshop since it is beyond coding workshop. So today's topic, beginners to pro backend engineering for full stack engineer. Most of the full stack engineer today are either front end engineer or backend engineer, or somewhere in the middle they are balancing. Oftentimes they struggle with backend engineering. So in that sense, you can say this is more for backend engineering for juniors and backend engineering for front end engineers who want to upskill on some of the concepts they don't understand in backend engineering. This is more of a beginner level course. We will be having more advanced workshop later on. I will share those details as well. What are all the workshop which is available for next weeks. You can go to our calendar, and in the calendar you can check what are all the workshops and what are all the things which is lined up. You can get an overview. So I do both backend challenges as well as Tamil engineering workshops. This is actually in language Tamil. So if you are focused on engineer like English workshop, then always check what is the language and then join the premium so that you will get the workshop access to it. Today's workshop is all about backend engineering for full stack engineers. So, if you are already a full stack engineer or a front end engineer, oftentimes you might work deeply on UI UX of it, but you might get confused a lot about backend engineering, what to choose and what kind of uh, things to do to make it scalable. Oftentimes, when you are working in a larger project, the main thing where things break is not just on the UI UX, but on the API or deep rooted into your backend system, like your schema is mismatching or your database. You are having a lot of legacy issues due to the database system, or the scalability, like it works on normal times but in high traffic it is not working. How to handle that? So those kind of issues is what you often face. So that is what we will be covering, especially for a beginner level, like what is needed and what are all the things which is there in backend engineering to go from there. So let's go into the actual content itself. So this is the table of content. Like these are the items which we will be covering today. We have short on time, so let's go and directly jump into the actual content of it. So you know how to write HTML, CSS, JS, and or React or Vue.js, whatever framework you are using for the front end, and you are able to connect your front end with some simple API or saving it in some CSV or some data format. Until that point, but do you know how everything works behind the scenes? Like when you are entering the URL and you get a beautiful UI, handle the state and making the API call, do you know how everything is working? Like, do you know how that data is getting rendered or that data is getting retrieved from the database? That is what we are going to learn. So you might have already like know how these pieces are working together, like HTML, CSS, and a form. And hypothetically, just imagine you created a business, and you created a landing page for that business with a simple form, and you are collecting emails to the wait list, and everything is working, and you go viral. Now you need to build on top of it. You need to you got the traction. Now you need to build on top of it. Now someone asks you, like, can I update my email? Can I unsubscribe? Can I see what I signed up for? But you just created a waiting list. You don't know how to do those updation and unsubscription and so on. So if you are using a simple data table or data sheet or CSV to store your data, that is the first problem you will face. It will work for just getting the data, but it won't work for edit and so on. So that is where you actually create your backend as well as your database. You might have question like, why not I just expose a backend database directly to the front end? Then security issues will be high. That is where directly, if you are exposing your backend like database directly to the front end, automatically anyone who has access to that is able to reverse engineer and able to steal the data, or even even worse, that they can delete your database. So that is where you need to have a backend layer where you need to transfer whether it is a proper traffic, whether I need to send my request to the database or not, your front end to back end, and from there. So if you are building just a landing page, then in most cases you won't need actual database. You will be just updating to Google Sheet or Airtable, or whatever tools, or even email list like MailChimp, SendGrid. You just add there. That will work until that point, like landing page. But after the landing page, what need to happen is like, you need to create a client server architecture. That is like, your front end need to communicate to the back end, and then the back end will communicate to your business logic, authentication, data validation, or a database. As I said, if you are exposing your database directly to the front end, the issue is security. You are basically exposing without any filters. So automatically any malicious traffic will take down your database or steal your data. That is where the backend is one of the main pillars of building an application, regardless of whether the front end is a mobile app, whether the front end your front end is a web app. In this case, in this drawing, I focus on web app, but it can be a mobile app as well. The backend is going to be the same. Okay, what is backend? A backend is just not just an API. Oftentimes we call everything as API, but it is not. A backend is actually a system, uh, which can be an API, which can be a long running process. I will come to that later. But a backend is basically a structure, rule, and memory. So where you are going to store your information, securely store your information and persist that information, regardless of you restart your server or change your server, that information will still resist in your rest in your memory. So that is part of your backend. And then structure organizes and validates data. That is like your API layer, or even any layer that actually validate your request, and validate your input. If it is malicious, then go to error. If it is not malicious, then go to your logic. That is what the structure is. That is, oftentimes we focus mainly on the structure, like we either using some of the frameworks like Express.js, or Python related frameworks, or Elixir related frameworks. Those frameworks will provide you that structure, and you will build on top of it, like how to structure your large scale application and do your backend API. Now the rules. Every API structure will almost be very similar, like regardless of which company is creating that, but your rules is going to be very different for different backend. For example, if I'm building an application for legal lawyers, then my business logic will be very different. My security need will be very different. If you are building a Facebook kind of application, then your business logic and security will be very different. So that is where the actual domain expertise comes into picture. Not every application will have standard rules. It depends on different application and different point in time as well. Like if your business is very mature enterprisey, then your security level need to be very mature. But if your business is very small scale, then then still you need to do simple secureness. That is always part of your backend, but you don't need to worry about ISO or compliance and all those things, because you are already a small. Okay, some error with the mermaid diagram. Let me see. Okay, let me run again. Okay, I'm back. Sorry for the interruption. Let me share again with full window access. That will be good. Yes. Here you go. Once again, let's come back to this. I hope you are able to see my screen. Yes. Okay. The request response cycle. So, what exactly happens from your front end to back end? You send a request, user, whatever endpoint it is. In this example, it is like sign up. The browser sends an request like API user email password. You will validate the input, whether it is a valid email, whether it is a valid password based on our structure. Then it will insert to the database and user is created, and then you will send it back to the browser, and browser will show success message to the user. So that's how, when you are actually doing a click or doing a request, that is what happens. In this case, we are using a sign up example, but in any case as well, like when you are clicking a button, the browser will send the request to backend, and backend will send that request to database, and database will share that request back. So that is what happens in a request response life cycle. You now have a backend, you have an user, you can update their email, you can manage their preferences, interact with your product. Where does the backend store its data? What happens when the server restarts? So if you have the backend API and it is communicating well and everything, but if your data is not persistent, like if you are not storing in a persistent database, if you are storing in a memory database or something, when your server restart, what happens is like you will lose that data. So that is where the database comes into picture. So if you are just storing it in your JavaScript variable or something like that, it will still be behold until you restart your backend server. But if you are storing it in a text file or something like that, that is also an option. JSON file or CSV file, that will persist on the disk, but what will happen is like you can't able to retrieve or update seamlessly. So that is where these databases are designed. You can put your data in a actual database. So as I said, like in memory data loss happens when server restarts, and you need to write the data to the disk, use a database that guarantee persistence. Restart happens but data remains. So that is where you need to store in a database like Postgres or MongoDB, and it will store it in the disk. And even if any restart happens, your data is separated from your, it is decoupling. Your data is separated from your backend, and your database layer will still be there. And even if you restart the database has written to the disk, they will be able to showcase the data. So that is why database is needed in a backend system. So these are very basic. In that sense, you might have already aware of, but I just wanted to make sure even a beginner can follow why we need a backend, why we need a database. We have come across those details. Now there are multiple types of database. I don't go very deep into it, like SQL, NoSQL, and so on. I will keep the content more beginner friendly, but as much as possible, in most cases, you will still be using SQL. I will touch a little bit about when to choose SQL and when to choose, MySQL. A database gives you app memory that survives restart, crashes, and deployment. Now, when the user update their email, the data persists. Memory is when what makes people trust what they use, right? So then automatically next time the user comes in, they will be able to see, okay, I enrolled for it and I am able to see my data. But how do you organize your data? What will happen when user emails are duplicated? So that is where the database and schema comes into picture. Like user emails were duplicated, orders references. For example, if you are building an e-commerce and your orders are everywhere, order related data is everywhere, product pricing are not consistent. In one page it is showing some other data, in another page it is referencing from some other data. That is where you need to create a consistent schema. Then only you will have a clear non-issue related to data. Like if you are creating those table with strictness around, okay, this data shouldn't be duplicated, this data is connected to this data is connected to this user, this data, product data, won't have duplicated pricing information. So if there is a pricing information, it will always need to consistently fetch from some place. If you are This is where the actual backend engineering happens. So if you design your data well, then it's always very very easy to design your backend APIs. But if your data is a mess, then it will always have a long lasting issue, because maybe at start you might design in a way for a limited number of user, and later on if the number of user gets add on, then that processes will become more complex and complex, and then automatically it will become very harder for you to keep up with the data chaos. So it is always better to first design your database and then design your API. That way you will be able to consistently make progress with your schema. So how you can solve the duplicate issues, or inconsistent data issue? Most of the standard databases like Postgres and MongoDB will already provide, especially the relational databases like Postgres or MySQL, already provide you best practices on how to enforce that. So even if you follow a standard practice, then you will be able to get a very good database schema. Now if you see a sample schema here, like user and order, so user ID is here with the order. Then order item will also have order ID and product ID. So automatically if you create these relationship, automatically you will be able to reference. So if anyone is asking, hey, who ordered this item, then automatically you will be able to fetch, like, okay, order item have order ID, and using that order ID you will be able to get the user ID, and you will be able to get the name of that user automatically. And you can also check, hey, who are all ordered this product, then you will have the order product ID, and using the product ID you can reverse and check who ordered these product. So that is where the schema makes it easier for you to develop your application. So schema design principles, like what are the rooms, um, like it's an analogy, when you are actually building a schema, you think like you have rooms, and your rooms is actually your main tables, like users, orders, and products. What furniture is in the room? So that is the column inside that tables, like name, email, price, whatever that is relevant to that table. and then the relationship between those rooms, like how the rooms are connected or how those tables are connected. A user places many order, so, or the user buys many product through that order. So it can be in that single order itself, they can add multiple product to it. So that is what you need to decide or design in your schema. Now some of the rules, as I said, like the constraints, like email must be unique, price must be positive. These are all the constraints you need to add in your database. So schema benefits, why a database schema will help in your backend. It will provide you data integrity, it will provide you performance, it will provide you, maintainability for regardless of whether you have zero users or thousands of users, you will be able to maintain your code base consistently as well as your data consistently, and you can refer back even 3 years old or 5 years old, like a file, you can able to get back to it and able to do analytics on top of it very easily if you have a very good schema in place. Now the observation, like you have the data integrity, you have fast queries, you have maintainability, you created a product table with price in stock and in added data, but cart collection broke, what went wrong? So you created the product table with price and stock information, but still the front end broke. What can went wrong? It is basically the data type problem. So for example, when you are actually having your schema, the columns, what you are defining, you need to make sure you define the columns with proper proper values, proper data types. For example, whether it is an integer, whether it is a string. So if you are adding 10 plus 10 as an integer, then it is 20. But if you are adding 10 plus 10 as a string, then it is it will add up like 10 10. So that is where you need to be very careful on when you are defining that. And if it is a boolean, then for example, in stock is equal to true, then it is a boolean. But if you are storing it as string, then it won't be right. So you need to make sure use correct decimal, correct boolean, and so that database will have proper data, not bad data. Okay. So type safety is very important when you are, these are very basic in that sense, most of you are well aware of, but still it is a very very important lesson, because changing it later on will always be difficult. So it is better to do it from the start to follow best practices. Data type benefit, as you see, like one thing is safety, and another thing is calculation efficiency in terms of calculating, and another thing is speed. So querying with a number or querying with a boolean will be much efficient, much faster than querying with string based all the time. Okay, so these are some of the data types. This is from Postgres, so you can check it out, like integer, float, varchar, text, boolean, date, time, timestamp. Let's go into the next one. So the next chapter is about SQL versus NoSQL. Before going into that, I will simply recap what we learned. So you have a simple front end with no database. You just have a email list functionality, and then you created, you added backend to it, and you added a database persistent layer. Now you have a full-fledged front end, backend, and layer to it. Now comes the $1 million question. It's truly, literally $1 million, or even billions in stake, because most of these database companies are huge. Oracle, SQL, Microsoft SQL, Postgres. Postgres is open source, but like the services who provided Postgres, Neon or Supabase, and so on. And then MongoDB Atlas, DynamoDB, these NoSQL databases. These are very big companies behind it, or Redis, for example, in-memory database, or even vector databases like Pinecone, BB8, Quadrant, and so on. So how do you choose when to choose what database? In my opinion, all the time, always go with SQL, relational database, since most of the data need will be easily satisfied with Postgres or MySQL or any relational database, even SQLite. um, but then there are places where you still need to choose, if you are building Udemy, or if you are building Uber kind of thing, you won't choose just one database for all, but rather you choose based on what is the need. So for example, um, yeah, you have a lot of data logs, then you might use BigQuery or MongoDB for those logs, because those are more like streaming logs. You will be just storing unstructured data, and then you will be processing those in your data logic. For example, Uber will be streaming each and every position of the car, and car is moving, and they will be streaming the longitude, latitude, and all these data, and then they will be processing using their data. Their data engineers will be processing later on, like what is the shortest path for this, at what time, the traffic has been. So they will analyze this data. The ML engineers will analyze this data and they will say, okay, in Italian city, 5 to 6 o'clock will always be having heavy traffic. So you provide, this is the best path to cover the city area. So this path is always not a good idea at 5 to 6. So automatically those algorithms will be drawn back, and that will be used to have a decision making inside the application, like uh, at 5 to 6 o'clock I have an alternate route, even though it is 2 minutes, 2 minutes extra or 1 kilometer extra, but this is more efficient, like not 2 minutes extra, but 1 kilometer extra, but it will go 2 minutes lesser the place. So those kind of data analysis, high volume logs will always be used in with something like MongoDB or things like that, like mostly the unstructured data. But anything which is relational data, it is better to use something like Postgres. So that way you will be able to enforce your rules and schema from early on. That way it will be much easier for you to scale further. um, like some other use cases, maybe I will say, for SQL, limitation is like, mostly it is logs specific, but that log can be even transactional logs as well. So for example, you are in an enterprise scale, you might have transactional logs. Yeah, a good example is like LogRocket, for example. When you are going to LogRocket, you can go and view all your session, and there are so much of data that goes in each session. You don't need to get all these information in a structured way, or one session and another session might not be connected in a distinct way. Only the user connection will be there. Apart from that, each sessions are independent, so you can save such details as JSON log, or some kind of log where you stream that information, and you will be able to get those information. So maybe it is too high level on a product specific I'm explaining, like Uber or LogRocket, but there are applications which requires very dynamic data set, which is not very relational. In such cases, it is better to use NoSQL. But there are places where these logs are relational as well. That is where tools like BigQuery, which is used, those ones are still, like, you can keep a relationship. So it is like a better of both world. You will still have high volume of data, and you will be able to do analysis on top of that data using partitions and so on. So here is an example of uh, to be honest, this is not the best example, but yeah, you can see, like, for different data types, we just store the material data like JSON. In this case, to honestly, I would say even Postgres will able to do, because Postgres have JSON B queries. Only thing is, it will be slower than MongoDB, but in most cases, as I said, it will be able to do it. Now let's compare for your application. If it is a structured data like billing users, then you can have user table, course table, enrollment table. So if you are building like an Udemy or kind of a course platform, then you can able to store those one to many or one-to-one relationship directly in SQL. But unstructured data like materials, videos, PDF, related information, or those ones, you can keep it in NoSQL, or in that sense, I think it's not a very good example. I would say Uber kind of example is much better example in this case, but this can be stored even in SQL database as well. But for example, in Udemy as well, when you are doing yeah, when you go to Udemy, you search for courses, and you will see a list of courses, and you will get a lot of recommendations. So these recommendations are based on user preferences. So you store these user preferences in your user database, but how do these recommendations are stored? Because these recommendations are not exactly data, but rather it is a log. Like today, your recommendation will be different based on your behavior for next couple of days. Your recommendation will keep on changing. So it keeps on changing. So whenever there is a data layer, uh, or the data engineer who run their batch processing and do the recommendation, they usually prefer something like a simple JSON database, like an unstructured database for those, and you will be able to fetch those information. So that's how recommendation engines usually work. The choice isn't about which is better, but rather what works for you. So oftentimes, my go-to choice is always SQL. So go for perfect data which is structured and related. When you have certain data set which requires NoSQL, then you can always opt in for NoSQL for those data set alone, and then expose that data via a microservice API or something to the main database. That way, you will be able to get the best of both world. In most cases, as repeat, SQL is the best option to go with. Okay, hybrid approach. As I said, many teams use both, especially in a large scale application. SQL will be used for the core application, and NoSQL will be used for activity feeds, logs, and so on. Activity feeds, for example, in Facebook, you see a log of feeds like what is happening, who liked your post got this many followers, and all those information. Those are just feed of information which is unstructured, because it has very different information from different databases. Okay. Practical example for SQL and NoSQL. SQL you already aware of. For NoSQL, activity logs, shopping cart information, user session like temporary information. So session expires, and after that user need to recreate their session. So those kind of information. And then in most cases, user sessions are usually managed in memory databases, not NoSQL, but in a large scale application. It is possible. Content with varying structure. So applications like legal application or immigration related application. For example, I work for Japadical, and there the content differs from country to country. So in one country, the forms will be entirely different. In another country, the forms will be entirely different. In such cases, it is better to use NoSQL. Okay, now let's go into the next challenge. That is, you created tables, you know what is database, what database to pick, and all those things. Then um, user changed their email, you updated the user's table, but the confirmation mail went to the old address. Why? So you created a user purchase table and put everything in it: username, email address, course title, price. Then user changed. It's a hypothetical problem. In most cases, you might not put all these information. You will be putting those information inside user table. But yeah, let's go into the next module, that is HTTP and API fundamental, how front end and back end communicate. It is always easier to create any API endpoints wherever you need. You just create that API endpoint, but that is not the right approach to go with. You need to always make sure whatever you are creating in terms of API endpoints, that is consistent. That is very important. So the main issue is like, if you change an API or any anything in your backend, then automatically the front end will be broken, because front end will be sending in the data in different format. This is where API consistency is very important. So if your API is not consistent, then automatically it won't work very well with front end. Also, front end doesn't mean, for example, for Uber, the front end like for Airbnb, the front end can be web app, the front end can be mobile app, the front end multiple mobile apps actually, like driver, like Airbnb host will have one mobile app, and Airbnb users will have one mobile app, and then partners will have very different web app portal. You need to have a clear contract. Even if you break one thing and you tested only one mobile app, it might break another app. So that is where the API contract is very much needed. You need to have proper version control, proper API contract. Then only it will your all your front ends like web or mobile apps will be able to communicate with you consistently. And even on bug fixing iteration, later on you will continue to have a proper working application. Otherwise it will become very very hard to manage. An example of it, like, consider API like a menu, restaurant menu. So the same way, what you are seeing in the menu is basically like a contract, where you are reading what is available, what is not available. So the same way, the API documentation will expose what is available in that API and how you can fetch that API. What is the format you need to send the data to the backend, and what is the format you will receive the data to the front end. So that is what the API contract is. Like, if you pass a get request, then it will find the user and it will send the user back, and it will send the user in certain format. So this is the API format. If the API contract is fixed and properly managed, like if you use a standards like GraphQL or REST API, then automatically you will able to build a scalable and complex system very much easily, because your front end and back end will always be in sync. But if your API is everywhere, you are not having proper structure or standards, then you will have problems later on, that you will face issues with your API. So HTTP method problem. So when you are actually using a wrong method like get user, delete user, and create user, uh, the bot will crawl and just delete, fetch this delete endpoint, and your user will be deleted. So that is where HTTP method will be very, very important. Like a bot attack can happen as well, like user slash create, and they will be able to create thousands of users. That is also not a good idea. What is HTTP method? Like you need to put different methods like get, post, put, patch, delete. Then only that API will be solid enough. When it is get, it is safe. When it is post, it is create. When it is put, it is update. When it is patch, it is partial update. When it is delete, it is very, very dangerous. So that way, only the get request will be the read safe, and you can always have your front end very calculative that it won't send accidental request to delete any endpoints, delete any data. Okay, so the Google bot comes in and try to delete. If it is not a proper endpoint, then it will be dangerous. If it is a proper endpoint, then get user will always be get user, not a delete endpoint. Okay, as I said, get is the most used or overused as well endpoint, because that is reading your data out. So oftentimes you will be reading the data and you will be fetching that information and providing that information to the front end, and front end will be painting that UI based on the read data. Post is used for creation. Post and put will be used in equal size, mostly creation and updation. Those are post is not idempotent. Idempotent in the sense, whenever you are whenever you, what does that word idempotent means? When you are sending a request with same input, same output will happen. Like in a read endpoint, same output will happen. In a post endpoint, same output won't happen. Each time it will create new resources. For a put endpoint, same update will happen. For a patch, like partial update, it is not idempotent, even though it depends on how you implement it. In some cases, patch will also have idempotent if you implemented it that way. But if it is not implemented that way, like it will include both put and other operation like delete, then it is not idempotent. So basically, whatever input you have and the same output comes in, then it is idempotent. But if it is not, then it is not idempotent. So that way, you can, when you are designing your API, you can always design like, okay, whether we are doing only read operation, then use that endpoint. Don't mix too many things inside one endpoint. Like don't mix like it reads some data, it writes some data, and all those things. There is a philosophy called single responsibility principle, that engineers, it's one of the best practices in software engineering. Make sure your endpoint, your API endpoint is modular, and it focus only on single responsibility. That way it won't be doing too much than it should. Okay, now HTTP methods are just y of the requests. They are most basic layer of API security. That alone is not going to make your API secure, but that is the first step of making it secure. Now, what about authentication? How do you check if a user is logged in before every request? So that is very important, because if the user is not logged in, Then if you are not reading it and you are giving access to some data leak possibility can happen. The malicious user can try to steal some data, or user can do mischievous action. So that is where the second step of the security is where your API endpoint, you have 20 different endpoint and you wanted to authenticate, then how do you go and authenticate? In this case, authentication need to be done, but how do you approach that? You need to create a centralized, instead of duplicating for each endpoint and miss out, like you might have done for 18 and you missed out two of them. You create authentication middleware solution, and when the request comes in, at that point itself you will ask, like, okay, is this a secure call, API call, whether that user is authenticated or not? User request comes there, and middleware will log the request and it will check authentication. If authentication is good, then it will go to the endpoint logic. If it is not good, then it will go to 401 unauthorized. That way you will be able to avoid any unauthenticated thing. There are a lot of different middlewares you will write. Some of the middlewares are, one is authentication. That is, authentication is like just basically saying whether this user have access to that or not. Authorization is checking whether this user have authorization to do that action or not. Authentication is like, for example, okay, these all are this person is X, this person is Y, this person is Z. Now X, Y, Z, everyone can do the same level of operation. So authentication alone is not enough. In an actual application, there can be admin, there can be normal member, that can be read only users. So in this case you need to authorize as well, like, okay, whether it is a read only member, whether it is a admin user, or whether it is a member, based on their permissions, you will authorize, like, okay, they can do a delete action, this user can't do a delete action, and then log all the records, so that later on if something happened, you can go back and check who did what, where did the issue happen, and you can able to trace back how to get it. And then course, you might have already heard, especially for front end developers, you might have hit many issues with cross origin request. For example, if you are sending your request from domain A to a subdomain, if your subdomain is not accepting request from any other subdomains or domain, if your backend is not allowing that request, then automatically the CORS will kick in and it will send an error. So you need to say what are all or secure endpoints which can fetch. This way you can avoid any malicious attack to your backend. Someone who is trying to put your backend directly on their website or something like that, you can avoid. So that is why it is needed. And then another common middlewares is like rate limiting. In larger application, if someone is abusing, like, just create a function which will hit 10,000 times to the same API, then your API will be down. So you need to make sure to rate limit. Okay, if a specific IP is accessing within this window period, like within 1 minute, hundreds of requests, then rate limit that, send an error, and then after 1 minute once again allow them to do it. So those kind of middleware will be built as well. Validation, this is very very common, like input validation. When you are sending an email, if you are sending a dummy text instead of email, if you are not validating, you will save that information to your database, and then all your functionality which is related to email sending and all those things will break, because that data is not a proper email. So those validation need to happen in both front end as well as in the back end middleware. So how does a middleware work? Request comes in, You log the request, authentication check, and endpoint logic. So authentication check is just an example middleware, but there can be many different middleware which you can build before it goes into the response phase. That is the endpoint logic. Okay, so far I hope you have enjoyed until this point. If you have any queries or any questions, please feel free to ask. So basically we learned why backend is important, why data persistence is important, and why you need to have a proper API, like a standard API like REST API or GraphQL. So all these basics is what, why, and what is the reasoning behind all these is what we have learned. And we also learned the request response life cycle. That is your request comes in, and it will go through different layer of middleware, and then you will be sending the response. So that is what we have learned so far. Okay, let's go into the next challenge. That is, you have built 20 courses, and your all courses page is working completely fine until 20 or 100 courses, but years later you have a lot of courses. For example, Udemy have 50K courses, and if they are trying to load all the courses on single page, then it will break, right? So how do you make sure, how to avoid that? Think, okay, I think there is an inconsistency with the content. Okay, I will go into the security fundamentals and then come back to that challenge. The security fundamentals, like until now, what we have seen is like, okay, we will build basic security, we can build authentication, authorization, but beyond that, we still need to make sure we shouldn't be storing any password data to the database. We need to make sure it is hashed, so it is not like any user who is able to fetch some information, or anywhere where we are sending that information, we will have issue. Like if there is a breach, if a hacker is able to inject SQL and able to find able to download entire user database, then they will be able to leak plain text password. So those kind of silly things should be avoided. The hacker is even in most cases users might be reusing those passwords, so automatically. So these are very basic fundamentals, that anything which is password kind of, not just password, like any secret code or anything which you are storing, you should always hash it, so that it won't be a big disaster later on. The password hashing works like this, like you have a hash, and you will use that to hash the password, then it will create a value. Then if hacker is able to get that, those hashes are useless, because you are not storing, you only know the salt information for that user. So unless and until the hacker knows that what is the salt information which is used for that server, they don't know how to crack that password. Okay, so this is how it works. Like you have a salt created for Alex, and then you will use the password, and then you will be able to get the hashed information: email, salt, and hash. So you just need to store the email, salt, and hash. You don't store the password. Okay, let's go into the salting. Before hashing, you add a unique random salt to each password. Now, even if user has same password, their stored hashes are completely different. Yeah, this is the reason why we do the salting. There are many hashing algorithm. One is Bicrypt. This is one of the most famous one, and then Argon 2, script, and never use the basic one like SHA-256, SHA-1, MD5. Too fast but vulnerable, because user can able to brute force on those occasions. uh, what else? I think roles. The second security is defining a role, like whether it is an admin, whether it is a member, whether it is a normal user, what kind of role which is defined. So in some cases it can even be like whether it is an admin, whether it is a department head, whether it is a HR. So different user, whether it is an engineering group, different user have different roles. If you are writing all these logic in your product directly with if else kind of statement, then it is not scalable, because no, you can't reuse that anywhere. If it is just a role specific permission, like okay, this user with this role can have these permission, then you will be able to easily handle that. Roles and permission will solve easily, like you can define, can delete user, can edit courses. So you assign, okay, for this role these are the permissions they have, then automatically in the front end, if that user have that role, then you will be able to in the back end, you will be allowing the API endpoint to proceed with that operation. So if a role doesn't have can edit courses as information, then they won't be allowed to edit that course, because they don't have their information. Here there is one tricky part, what if yeah, we are just storing information in boolean alone. Can delete user, can they able to delete all user? No, you should still, roles and permission alone is not the only thing. You should still check whether this user have authorized to, he can delete user, but does he deleting the right user, especially when you are building b2b softwares without tenancy, like you store all the customers in one go and each customer can have their own users. Then you need to have one more layer, that whether they have permission to do deletion for this customer or not, are they belonging to that customer or. So that happens, that is even more advanced in my opinion for b2b application. If you have a very good tenant based architecture, then it will be much easier to handle those. But if not, then you need to design that in your roles as well, roles and permissions as well. So RBAC architecture, like for example, permission can delete user, can edit and user role admin. If user dot has permission, can delete user, show delete button. If not, don't show. If you are hard coding it, then it will be very hard to scale. I don't think anyone is hard coding. I'm just adding it to make it as an example. But yeah, that is where the benefits of role based access control. This is one of the main concepts of any scalable backend. So definitely I will share more detail or more depth around this later on. And then database operation, like automating database stuff, like forgotten update problem. The app was working well, but the team was growing and small bug keeps slipping in. New developer forget to set updated at timestamp. When a user changes their name, now the data was wrong. Another developer forget to add an entry to audit log table when the course was deleted. Now you have a record of who deleted it. Like human error can happen. So it's very hard to say, hey, please update timestamp all the time. Instead, you need to use database triggers, that whenever there is an update, always updated it. Whenever there is an update which need to trigger a log, then it need to trigger a log. So that way you don't need to force the user to do it, but rather the system to do it. Automatically the system will update, and it will add it to the audit log. In most cases, audit log table might be inside the SQL databases itself, but in large scale application, audit logs will usually be outside of it. Like you will log it, like you will stream the log, and the logger will capture, and it will add the logging to any databases like BigQuery, or even to the log like GCP logs, and so on. Triggers move critical logic from I hope the developer remembers to developer guaranteed. To be honest, this is not the only thing which is used for trigger for. Triggers are used for many things, like whatever logic that need to happen afterwards, any calculation that need to happen in the database level, that will be done through trigger. For example, I am storing a data related to product, or related to my behavior in a product. Then a recommendation engine need to do an analysis, but it is very costly to do it straight away when you are saving it. Then in those cases you can create a functional trigger in the database. So whenever I update something, then that trigger will trigger, and that trigger will do the calculation, and it will save the information afterwards. So any such logic can be used using triggers. It is very powerful. We'll share more in depth later on when we are having Postgres and MongoDB related workshop. Now the product team keeps asking for report. You write the same complex 20-line query over and over. How do you simplify this? The repetitive query problem. The product team loved your app, but they were always asking for report. Can I get a list of user who enrolled in a course this month with this name, email, and the course title? No problem. You wrote the complex SQL query with join where, and an hour later another request, same report, but for last month you ran the query again. This is where the views comes into picture, like database views. Like you don't need to run the same query again and again. Rather, you can store it in the view. Like, okay, this is the view I want. It doesn't store any data. It is just a saved query that looks and act like a table. Whenever there is an update, automatically the view will get updated. You took your 20-line query and create a view. Now when the product team need a report, you query becomes simple. You just query the view instead of directly. You just say select from month, enrollment, and category is equal to finance, and you will be able to get the view out of it. So view architecture is like it's like a, you can say, read table. View is more like a read table, like user, courses, enrollment. Product team can directly access that database view, and these views are actually there in many databases. Even in BigQuery these views are there, and SQL, it is there. And to be honest, these views or having different names in different databases. So probably you might have heard similar thing in many databases, but the naming might be different. Okay. uh, Anything else? The schema sync problem. Your app was growing. Your team decided to add a phone number field to the user profile. You opened your database tool, connected to your local database, and ran the SQL command. It worked perfectly. You wrote the new front-end code, tested it on your machine, and pushed it to production. The production crash. Every single user trying to update their profile got 500 internal server error. Your code expected the phone number column to exist, but the production database didn't have it. In your panic, you have forgotten the important step. You never ran your SQL command on the production server. The database migration. So the database works with migration. That is like you need to update your database changes. It is basically like Git. You need it's an automatic version control, where you need to migrate the new schema. That way you know what you are migrating and what you are actually updating in your database. You can keep track of what you did so far, and what is working and what is not working with it. So you can go back in time and check what is the schema before, what is the schema now, and what are all the old data. While running migration, oftentimes you might need to migrate some data as well. That's a rare case, but in a legacy application this can happen. When you are making a breaking changes to your existing data point, then you need to migrate the data as well. So this is very important step, especially this helps you to enforce your schema well. So if you haven't added that column to the production database, then your production database will break. The benefits of migration: your code and the database schema are always in sync. You can never forget a step. So if you add that migration, then automatically in your CI/CD, like you will run that migration and automatically it will always get updated. So always keep the migration in your GitHub, like in your Git log, so that it will be added. Okay. So the next challenge, I think I read this challenge before as well, but that was misplaced in that section before security. But here is the right one. You build all courses page. It made simple API call. It worked with 20 courses. Now you have 50,000 courses. Of course, I'm making it up, but in a Udemy context, for example, they can have 50,000 courses, so they can't list all these courses in one go. So how to build a production ready API which handles that? Then you need to have a pagination. What is pagination? So for example, you might have seen many places where 1, 2, 3, 4, you can click on that. In some cases you scroll and automatically it will load data again and again. So this is pagination. It will fetch the first 20 data, and then it will fetch the next 20. It will fetch the next 20, next 20, next 20. That way your server won't get overloaded, and you will be able to get consistent data from there. And now the server won't crash, your front end won't crash, and you will still be able to download 50,000 row from the database. So if you are, or you can able to download whatever the user actually want, and you will be able to showcase the data. If you are trying to download 50,000 row from the database, then your database will spike. Your server will not able to handle 100 MB of data which is transferred. You run out of memory, it will crash everywhere. Like browser will crash, backend will crash, as well as API, like C, like database will crash. But if you are doing it step by step, then it won't. This is what happens when you are smart enough to build your API production ready. When you are actually creating it, you need to foresee it, which of the API endpoints that is needed to be a pagination, and then you will be able to handle that automatically. So you create something like this, like courses page 1 limit 20, then it will create only the 20 items from page 1, and you will be able to solve it. So if you are offsetting it, DB will only get 20 rows, and it will be, I'm making it up, 50 KB. Most probably it won't be even 50 KB of data for 20 rows. Okay, let me, sorry, my sharing went away. Let me share again. Yeah, pagination types. There are many ways to paginate. Offset pagination is one thing. Cursor pagination is another thing. Like When you are working on a large data set, then you can do a cursor based pagination, so that you can call the next item, next item, next item, and you will be able to work on it. But in most cases, on a page related pagination, in my opinion, it is better to go with offset based pagination, because usually user won't fetch beyond couple of pages. They will always use search functionality to search what they want, rather than going and getting all the courses they want. And then filtering and sorting. Filtering is, as I said, like the search functionality. You can filter whatever category you want. You can sort based on your price, or you can do this is also one of the best practices when you are building API, because when you have a humongous amount of data, it is better to have filtered view. Nowadays, most of the applications are even doing personalized data. So for example, if I am viewing it, then it will only show in Udemy. If you go and see, I won't see photography or social media, or some acting related masterclass or anything like that. I only see coding related ones, because based on my user data and my preferences, it will only fetch certain categories, and it will only show that category of list, unless and until I go and search explicitly for some other courses. If I am not logged in, then it will be showing some of the top random ones, so that I will be getting hooked, or based on my search traffic data or analytics they already have, they will provide some information. So this is where the filtering and sorting of your API endpoints will be very very useful. That way you can make your API very performant, highly maintainable, and you will be able to withstand any traffic easily. Then the documentation problem, like oftentimes this happens in a medium scale to large scale API. In a small scale API, mainly you will be the one who will be doing the entire full stack, like front end, back end, database, and everything. So you might be able to handle it. But when you are actually exposing your API, like Slack API, for example, when you are exposing it, you know, to end user, then you need to have a clear documentation, public documentation, or even in a private API, when you have multiple teams working on your API, like multiple teams are consuming the same API, like companies like Pipedrive, or Wise or Bolt. Those companies will be having multiple teams using the same API. Then in those cases it will be very very hard, like Twilio. Then it will become very hard for you to uh, uh, reuse those API unless and until you have a clear documentation. So in most cases, API documentation internally, I recommend something like Open API Swagger kind of solution, where you can test out your API easily, and you will be able to enforce some of the API best practices as well. So it will already enforce some of the documentation, and it will be running documentation. It won't get stale documentation for you. So in that sense, I think the best option is to go with Swagger. But for a public documentation, I think that approach is entirely different. Even for a public documentation, mainly you need to create open API kind of documentation, as well as you need to write your own markdown based docs to provide clear idea. And then you need to create version controls as well, like version 1 of API, public API, version 2 of public API. So when you are moving from version 1 to version 2, these are all the things which will need to be migrated, and these are all the things which will be deprecated, and how to use it in new version. These kind of documentation is needed for public API documentation. So the documentation will include like interactive docs, contract test, and some code generation, like how you can use it. So this is one thing we will be seeing in third week of third week, or in couple of weeks, we will be seeing this this workshop. So stay tuned for that. Like I will be showing like how Swagger open API documentation can be used in a production level. Now, key takeaways. I think when the mobile dev asks a question, you don't send a WAD document, you send them, of course, yes. Yeah, you send the live document so that they can read and they can able to follow. In As I said, public documentation is different from private documentation, but still for a private API, it is better to follow certain standards like open API, so that anyone who is developing with you is able to follow and able to use the API. In GraphQL as well, I think GraphQL already have schema. Automatically, you will be able to connect with Apollo based. It's a running documentation. Like with the schema itself, you can define what is the description and so on, and you will be able to get a clear cut, you know. Uh, Documentation out of it. Okay, I think we have covered the workshop or webinar for today, like the key takeaways or what is the fundamentals of backend and the API design and security, as well as little bit of database operation we have covered. Of course, this is very, very basic information. This is not hands-on workshop. Rather, this is more like a preliminary information for you to getting started with backend. If you have any questions, feel free to ask those questions. I will be exposing this as a standalone course as well, and making it available for free to the community later on. So enjoy your day, and keep me posted with your questions so that I can answer your questions accordingly from this. As I said, this is very much just the fundamentals. We will be going deep dives workshop later on. That will happen next week. That is scaling 0 to 100, 0 to millions of users. That one is a premium workshop, so you enroll for it. You will definitely be benefiting from that workshop. If not, you can watch the live recording, or you can you can use the course later on once we edit and put it. Okay, all the very best. Whoever is starting backend engineering, you can feel free to DM me. You can feel free to put your message in the group, so you will be able to follow along. Thank you. Have a great day.